today my lecture is basically a study of digital image processing technique to detect hotspot or any target, you can say that, with low resolution satellite data. Before going in detail about the talk, because I think that we will be here for 2.5 hours or 3 hours. So just some brief, because once the words come, remote sensing, there is nothing remote sensing. Means remote sensing means in Hindi you can say that sudur samvedan, or in English, without touching the object, how we can know the information about the object. And I think it is the duty of the computer science people that without knowing anything, how you are analyzing the image, or how you are saying that this is this target, or facing is smiling or not smiling, or crying or not crying, you are talking. The same thing. Once you are dealing with a very high resolution images, then you have a lot of opportunity, lot of things you can play. But once you are going to deal with a low resolution, because once we are talking image, I will give you one question. What is the difference between image and photograph? Just you can write, and at 6 o'clock we will just you can tell something. What is the difference between image and photograph? So once we are talking about the image, so everybody is thinking, okay, some pixels are, for computer science student will discuss, and they will think that, okay, some pixels are there. Maybe pixels are in 1 megapixel to 10 megapixels. But once we are talking the satellite images, then the resolution is very poor. So once we are talking about satellite images, satellite data or satellite images, the most important and interesting thing is its resolution. What is the satellite? There are two types of satellite. One is based on the radar images, and another one is based on the optical images. So before going to the detail, I will just little bit brief you what is the meaning of the optical images, what is the meaning of the radar images. The most interesting thing nowadays for the research purpose, the cost reduction. How we can reduce the cost, how we can optimize the use of freely available data. But we have to compromise a lot for the different type of things, because if it is a freely available data, then maybe the data is not very good, and etc. etc. So once we are talking about the radar images, so radar means its work. Everybody has, I think that has some BTech background or something like that. So they are going that radar means simply it works in a microwave region, and once it is working in a microwave region, so it is in layman language we are saying that microwave is totally transparent in the medium. Means there is a very less attenuation. Therefore, it is working as a radar wave. So, and once we are talking in optical means visible, near infrared, or thermal. So visible, our limit is there. If it is very foggy, if it is very hazy, then we cannot see. So with the visible, it is very important. It is very much weather dependent. Sun is there, night is there. In night I cannot see with the visible wavelength and all other things. But microwave can see. But today my talk is very much concentrated on the visible and near infrared images, how we can work. So another, just it is a brief. Today I am just going to discuss the optical satellite images, how we can use it. I will show you with the image. And there are two types of satellites. I think everybody is going. Nowadays an era where everybody is seeing upwards. Two, because why they are seeing upwards? Because they want to know all the things without going to that place. So we are trying everything we can get through the satellite, everything. People are thinking that, okay, you will write in the computer and something will come. It is not like that. We have to maintain, we have to make a database, we have to do a lot of work. Then, therefore, nowadays I am saying to all my PhD or MPhil students, please don't rely on the internet. A lot of false information is there. A lot of confusing information is there. Just go to the library, sit and say, see some books, maybe 1 or 2 books. But, so today my talk will be based on what is the motivation for this talk, why I have started this type of research work. Satellite data use, that is the most interesting thing. The study data which I have taken, because and then what the methodology. Anybody can use it. If you have a one simple PC, you can use it. If you have a MATLAB or C++ or something like that, so at least you can know and you can do some work. And so therefore, low resolution satellite images, that is NOAA. ABHRR is a sensor, advanced very high resolution. What is it again a sensor? It is a very less expensive or this data is freely available. Once we are trying to monitor the scene, so for a polar orbit it is very important. You know that it is a polar. Polar means every day you will not getting the scene. Either in 14 days or 30 days you will be getting the scene of the same area. So what the NASA people has done, they have 4 or 5 satellites parallel. So every day at least one satellite will look at that area. And second one is the low resolution, means approximately resolution or pixel size is 1 kilometer. You can imagine in 1 kilometer your spot is, any hot spot is something 500 or 200 square meter or something like that. So pixel size is here 1 by 1 kilometer. And the high resolution images are also available because now India, ICANOS is one of the best satellite of high resolution, and resolution is centimeter. But cost of the one image is 1 lakh rupees. So nobody, it is not possible to purchase more than 12 images for a year and all other things. So it is very expensive. So motto of this work, and I am giving the challenge to the computer science students also, or the teachers also. The motive of this work is how we can use the freely available or very less expensive satellite images, but we have to compromise. It has a very coarse resolution. Resolution is 1 kilometer. Pixel means 1 by 1 pixel, 1 kilometer by 1 kilometer pixel means in that pixel you will be getting one reflection. Therefore, I ask one question. First question for image analysis thing is that what is the difference between image and photograph? You must have to know that how the images we are forming or we are making the image and how we are getting the photograph. So once you are knowing that that difference, then you will be able to know what is actually image analysis or image processing. So 6 at 6 photograph once you will be finishing. So just you can think simultaneously and just tell something about image and photograph. So the problem is again, we have to compromise for 1 kilometer by 1 kilometer pixel size, and 1 kilometer by 1 kilometer pixel size means in 1 kilometer square area we will be getting one reflectance, because images means we are getting the reflectance from the each pixel. So we are getting, so it is very difficult to get, but it is a challenge. Next one. So it is important to explore the possibility to use freely available satellite data for subsurface detection problem or hotspot detection problem. Next one. So the research gaps, just next one. So a lot of gaps are there. People, why I am saying, I am working in this field since last 20 years approx. What I am seeing, people are taking one paper, just making some corrections and doing something. Publishing the paper is very different. Making a product is a very different. I don't know either you have solved some papers or not. If you will be solving any international journal paper, a lot of things are hidden. And it is very impossible that directly you can solve very easily that paper. So once you will be solving, so this is a lot of challenges are there. So what I have found that how we can, how I have to proceed or our group have to proceed in a different way. That is a very important thing. So either you are making a line where you are standing and you are the first person and another are the second, third, fourth, or you are just n+1. So that is so a lot of things are going on. Again, if it is the image analysis, so we have to think about the subpixel analysis, because 1 square kilometer area is quite high. So we have to think about the subpixel analysis. Next one. So the satellite data which we have used. So this is the satellite data AVHRR, and this is, I don't know either anybody has used the satellite data. There are a lot of types of this 1A, 1B, 2B, 3A, 3B. Why I am talking all these things? If you are trying to get these type of data, you must read what kind of data is there. Because satellite is seen from 300 or 800 kilometers from the Earth. And the most interesting thing, level 1A data, for example, level 1A data is the not calibrated, not georeferenced, and etc. etc. Calibration means maybe I am seeing this is the white color, but maybe you are seeing this is the yellow color. So how we can calibrate the thing? So because satellite is very far from here, and I don't know the reflectance what that satellite is reading, that is correct or not correct. So we have to calibrate. And then another very important thing, once we are dealing with the area of more than 100 square kilometer or 200 square kilometer, that's georeferencing. That same coordinate, what we are saying, it is represented by on the satellite image or not. So this is another aspect of the research for the computer science student. They are doing how we can georeference, how we can geocode. So this is the level 1D data, therefore. Because today I know that in India very few people are working with the satellite images. Very few people. A lot of people, they are working with the optical images, but there are very few who is working with the NOAA data or MODIS data. You will see the. So therefore I am talking all the details. What do you mean by 1B? If you got some satellite data, just first see the header. What does it mean? It means either georeference, geocoded, and two things are very important: calibration and georeference. And this is this area is a 5 band, 1, 2, 3, 4, 5, and this first band is the visible red, second one is near infrared, and third, 3, 4, 5th are the thermal IR band. So why I have selected this satellite images? Because as I have mentioned, either you are getting an image in a 6 month or you are getting an image daily. Especially once we are talking, then we are talking two things: temporal resolution and the spatial resolution. The spatial resolution is here approximately 1 kilometer square, whereas the temporal resolution is daily. Whereas in other satellite which has a very high resolution, they have a spatial resolution in centimeter, but the temporal resolution is maybe 2 months or 3 months or 6 months. So better temporal coverage. And as I have mentioned, these visible or these satellite images are very much weather dependent. So maybe in a day, today you got a lot of cloud, so maybe you will not able to get any image from the earth. So again, for this satellite we are getting a lot of cloud free scenes, and this is a freely available. So any end user, now I have given the product to the CMRI. Any day they can download the data, just putting our algorithm, they are seeing that at least 70 to 80% performance they are getting with the first hand module what I have developed. Second, for the sub-pixel analysis, as you are knowing that if it is a 1 square kilometer, then in 1 square kilometer maybe some houses will be there, buildings will be there, some forest will be there, some hotspot will be there. So for that purpose, we need a very high resolution data to mix either linear mixing or the non-linear mixing. So IRS, linear remote sensing satellite image data we have used for the subfiction, and this resolution is 23.5 meters, and these bands are approximately the same which we have used. Because once we are trying to compare the two satellite data, it is very important that both satellite data approximately should in the same band or same wavelength. Next one. So common problems, you can see that this is the satellite image of the Jharia region. Nothing is visible. You cannot differentiate what is there or where is the hot spot or something like that. So this is the common problems in the satellite images which we are facing. Low resolution satellite images are less expensive, but resolution is very poor. Inaccurate calibration, that as I have mentioned, inaccurate calibration, georeferencing, wrong predictions and conclusions. Presence of cloud, water and other noisy pixels may produce false alarms. So again, because this is a very weather independent, so we have to take care of all these 4 points. And then this is the satellite image, what the raw image which we are getting. It is very difficult to observe anything from the satellite image acquired in the visible spectrum. Next one. So once any student is taking admission for PhD under my guidance, I used to tell go and read the book Gonzalez, chapter 3, chapter 5, chapter 7, chapter 9, thresholding, segmentation, and image enhancement, etc. And again, I don't know. If you will read the papers and all other things, what you will find? Not a single threshold method is appropriate for all kind of images or all things. Every time you have to play, you have to tune. You are changing some threshold value starting from 0.1 to 0.9 in the interval of either 0.001 or 0.01 or something, and according to our result, according what is in my mind, this type of result we want, and you are playing and you are tuning and then you are getting. For any image, either it is your simple image or any satellite image. So that is the basic problems. So I thought that how, because every day we are getting one image, in 365 days we are getting 365 images. So every day if you want to tune an image for every each and every threshold value, then it is, you will be lost one. So you cannot survive, because every day you are spending more than 4 or 5 hours or 10 hours to just tuning and all other things. So there are two methods people are using for segmentation: fixed thresholding or the contextual algorithm. And for each application, as I have mentioned, and the contextual again depends on the spatial threshold. Contextual means by one to another pixel. What is the value of this pixel? What is the value of the neighboring pixel? But if you are in 1 square kilometer, so how you can say that this pixel value will be very much changed with the another pixel value? So people are using this one, and both methods what we are still using is not fully adopted. Fully adopted means today I have developed, I have fixed one threshold value. Either it is giving the same result for tomorrow's data or not. If it is not giving the same result for tomorrow's data, then there is no use. So for example, some fixed thresholding, for example, in band 3, people are using 320K for probable fires, T34 difference of the T34 15K or something like that. So again, a lot of contextual algorithm is there, for example, classic. Why I have quoted? Because these are the very common algorithms, and if you will be seeing in the book or in the literature, you will be getting. But each and every algorithm, there are some problems, because this is the fixed value, 8K. How you will decide that today image is the same as the tomorrow image? So again, you have a big problem. So this is the problem. Next one. Next. So next, back. Here you can go back. Yes. Next. So these are the problems. Next one. So objective for this research work, what I am going to discuss with you, to develop an efficient and adaptive contextual model for hotspot detection. Then using of some advanced technique like machine intelligence and the soft computing. And then some pixel analysis, how we can estimate the area. I will show you some results we have estimated. Pixel resolution is 1 square kilometer, and we have estimated the area in the 600 meters square or something like that. So again, it is a big challenge. Next one. So study area. So this is the study area, Talwar. All these are the Jharia coal field in Jharkhand. Jharia coal field, and all these are the hotspots. Hotspot is the subsurface parts. Next one. So it is located, because once we are dealing with the satellite image, we must have to know the latitude and longitude. Next one. So Jharia may produce best quality, although it is the best, producing the best quality of coking coal, but it is a big problem of the subsurface parts. Next one. So at present, what we have seen that, I will show you some results, because before this is a just preamble, what I am going to discuss, what is the basic problem and how I am approaching to solve the things. I have already published more than 10 papers for this, but nowadays paper is not very important, as I have mentioned. Product is very important, anybody can use or not. So next one. So you can see that this is the NOAA IVHR image for year 2004. More than 200 images we have critically analyzed, and these are the different images, as I have already shown in the previous slides, that band 1, band 2, band 3, band 4, band 5, all they have a different wavelength. Different wavelength means they are observing, for example, near infrared, that is more transparent for the fog and etc. and etc. So all these are, for example, band 1 and band 2 are very much important for the vegetation etc. type of thing. So each band has their own reflectance value and their own importance on the satellite data analysis. So once we are saying it is a large color composite AVHR image for the Jharia coal field, I will show you something. If you see this red spot, this some dark reflectance, it is the for the 3 bands in 3 band composite image. So you will see that some dark spots or something. it means we are getting the reflectance value different from the some other area. So it is our duty or responsibility to how we can select or collect the information from the this image according or providing some algorithm or with the some used algorithm. So these are some data. I have already mentioned more than 200 data. So why I am showing all these things? Once you are doing any kind of research or anything, and if you are doing from the India, so all the rest to our reviewer, they will asking, give me the details, what the data you have used, at what time it is acquired, all the full details. So you should be very much aware from the very beginning, because once you are trying to break their monopoly or something like that, so all these data which we have analyzed. So next one, that what time it is taken. So how you can start with the image? How you can say that this satellite image can give the response with the hotspot? So first important thing for any image is go for their spectral variation. What is the spectral variation? For any image, if you will see your any simple images also, people are working for a lot of Mona Lisa image and a lot of things we have seen that. But a lot of similarity of the work you will be seeing that. What the difference you can see, you can do. Either the lips as giving the different flavor with the chicks or not. That is the beauty of the work. So the same thing here also, either the hotspot, it is possible to get the information of the hotspot with these satellite images or not. So first important thing to go for the spectral analysis, and with the spectral analysis what we have seen that, this is the for the band 1, 2, 4, 5, what we have seen that this dark line is for the hotspot and for the non-hotspot, and this lighter line is for the subsurface hotspot. So what we are seeing for all the images is that this satellite has a potential. Before that, I have published first time result with the NOAA VHR data for detecting the hotspot and all that. A lot of some people has worked for the surface fires, for the forest fire and all other things. But we have tried. So from the very beginning, how you have to proceed. Because here I didn't come here to teach you something. I just here came here to just give you some glimpse. If you want to do really some research, if you want that your students should work. So how to start, how to give the problem, how to attain the problem, how to approach. So first approach for this, as my opinion. So what we have seen that, okay, what we have seen that, okay, it has a possibility. Next one. And then again, now I am saying this word, that is the PDF, probability distribution function. So PDF is again very important thing. A lot of image analysis people, they are not using this word. But again, PDF is a very interesting thing, because the PDF of the different type of targets must be different. And there are a lot of number of the available PDF like a Gaussian PDF, Webel PDF, a lot of things. So you have to check, cross-check. So we have, first we have developed the PDF. So Gaussian PDF, and we have tried to apply on the Gaussian PDF on the hotspot and non-hot spots. What we have seen that, you can see that the peaks are different. So it means we can play, first we can play with the reflectance value, second we can play with the PDF, or its probability distribution function, and it gets the very different peaks of the different size as well as the different amplitude. So it is possible to get playing with this, we can able to detect the hotspot. Next. Next. So again, if you are a image analysis person, then again people are asking how you have validated your result. So if I have taken your image, so I can show that okay, this is the person I have taken this. But with the satellite, it is very difficult. And then the auxiliary data which we are following, so the ground truth data is very much required. So what we are doing, we are going to the ground, we are seeing that what we are expecting, what we are predicting, either actually in the ground that is things are not, or if it is there, so what kind of difference is there, and our assumptions or their assumptions. So we have some collaboration with restaurant. So first task, and as I have mentioned, there are the big problem of adaptiveness, an efficient and adaptive contextual model for hotspot detection. These things you can do for any type of target identification, because the main aim of the image analysis is the target identification, how you are identifying. So, have you heard the name of the Rakesh Sharma? Huh? Rakesh Sharma? He went first time in the moon. So why he went? There were two reasons. One is the hidden one, and another one is the open one. Hidden one, because the American and Russian people, they want that you must have to see that what the Pakistani people are doing. So, and if you will see, because today I didn't bring that image, otherwise I will show you, if I will get any opportunity to meet you again, I will show you some results, because that is very interesting. How you can identify the target. With any photograph, it is very easy. It is a lips, it is eyes, or it is this, there. But it is a false photograph, it is not easy to identify the target. Either it is any helicopter, or it is any barrack or anything. So it is very difficult. In Kargil War also we have worked something with the Kargil at the time of Kargil War to locate the barracks. And you know it is very difficult because the area is so a lot of you can say the mountainy area. In the mountain it is very difficult to say that this is some barracks or this is the mountain. So it is very difficult to differentiate. So this is the problem. I have taken one problem, but there are enormous number of problems. Enormous number of targets are there. If you want, you can identify, you can take any image, just you want to play with from the very beginning with the spectral characteristic and all. So how we have approached after seeing a lot of gaps, a lot of things, and since last 15 or 16 years, I am just fighting to the rest world. Fighting means approach should be very different. Rest world people are saying, thinking that if you are making more complex, then your paper will be get easily published. But ultimate aim of the research should not be the publishing the paper. Ultimate of the research should be the for the society, for the serving the nation, or something like that. So the first important thing for any satellite, I have taken the NOAA VHR, so I am writing the NOAA VHR image. Any satellite image, calibration and georeferencing. Then again, just you can click. Masking of cloud and water pixels. This is known as the pre-processing. How you can mask, because these cloud and water pixels are giving you the false alarm. So there are some methods, available methods, how we can mask the cloud, how we can mask the water, and then finally this is the pre-processing, because masking in another way you can say that the leveling. Either you are padding, 0-1 padding. 0-1 padding means whatever you want, that is for 1. What do you don't want, that is for the 0. So this is the some methods available, or if you want, you can play with this, and then you can get actually land, because we are going to play with the only land features only. So this is the water bodies and cloud we can mask, and finally we got the land. Next one. So then this is the very interesting and important thing, how to approach. Using the model and development of model is a very different thing. We have started to approach either these freely satellite data is useful to detect hotspot or not. For that purpose, we have applied our first approach, because reflectance values are given. So we have tried to do some spectral analysis, and then with one, because you can get a lot of, there is a lot of possibility to get a false results, because satellite is too far. So second important thing, with the cross-checking of that. So what we have checked, I have given you the clue, because if you will see the lot of paper, they are not using the PDF. So with the PDF also, you can cross-check what the results you are getting, either it is true or false, or what kind of nature is there. So we have played with the percentage of reflection, that is the raw value for any satellite data, for the each pixel, then brightness temperature, and the vegetation indices. Vegetation indices means That is some type of reflectance value for the special type of vegetation. If fire will be there, 100% sure there will be no vegetation. If fire is not there, then we are assuming there will be some vegetation or something like that. So we have included one more in this next one. So what we have classified after that, we have classified these results, first hand results, like this is the image, then after all the process what we have seen that these are some of the hot spots. So in this hot spot again, I think that already you are knowing that the reduction of the false alarm, how we can reduce the false alarm value. Because once you are taking the more threshold value, this is thumb rule, if you are taking the threshold value high, then it is more possible to get more false alarm. Once you are going to reduce the threshold value, then maybe your accuracy will decrease, but the false alarm value, false value will be decrease also. So this is the aim. Next one. This is the loss at light images. The algorithm which we have applied for removing or masking the cloud and water. So we have removed, and you can see that this is the cloud, this is the water, and this is the green one is the line pixel. So our aim was to remove the cloud, remove the water, and only we have to play with the line pixel. Next one. Next. Yeah. The interesting thing for image analysis, this is the approach, the how we can develop the model. Application of the applying the different model is different. How we are developing, how we are thinking to develop the model. Next one. What we are saying that for developing any unique model or any adaptive model, you must have a large number of data. So we have applied this our analysis for the 70 AVHR of images. Next one. So what we have checked for the percentage of reflectance value for hotspot pixel in band 1, band 2. It should be the less than the background pixels values, and then radiometric signal. All the I can say in the very layman language, whatever the first hand information is the reflectance value that we are using to develop our critical observation for the model. Next one. Again, with band 3 and band 4 and band 5, we are getting the brightness temperature, then we have played with the brightness temperature. Next one. As I have mentioned, we have played with the vegetation indices, but we are thinking that if the hot spot is there, then there is a less possibility of vegetation, whereas if there is no hot spot, then there is a possibility of the vegetation. Next one. So, what should be the algorithm's input? So, first is the what we have. We have the pixel and we have the reflectance value. There is nothing with that. If we have a one image, then what we have? The number of pixels and the reflectance value. If it is a 5 bands, then we have a 5 types of values. For example, here band 1, band 2 has a different reflectance, band 4, band 5 has a different reflectance. So, and another important thing, once we are talking about the spatial, for the spatial analysis, we must have to know the pixel statistics. How the pixel values are changing from one pixel to another pixel. So, therefore, we are calling it, what is the pixel statistics? Average and variation of different bands, and then the statistical information of NDVI, that is the normalized difference vegetation index. Why we are applying it? We are applying it. So therefore, there are a lot of type of indexes which we can apply for the different type of targets. And this is the main aim of this. We want to develop some algorithm which should be the very adaptive. Very adaptive means it can be applied for the different date of the same data. Means we have developed for the no IVHR data. But if you want, you can play with something and you can apply for the modest data also or different type of satellite data. But once you are trying to use for this still camera images or the video images, you have to, because their pixel resolution is very high. So you have to play it differently. So after doing comprehensive analysis of 16 VHR images of 12 years, so we have fixed some markers. What we have till now, we have in our hand pixel reflectance value for the 5 bands, Then we have developed, we have told one more thing, that is NDVI, that also depends upon the ratio of the reflectance value. Third very important thing, what we have, the pixel statistics. Image statistics we are saying. What is the image statistics? How the reflectance values are changing from one pixel to another pixel, or 1 to 3rd pixel, or 1 to 4th pixel. So we have fixed, because ultimately what we have, we are taking a image from the satellite and the raw image, what you have seen there. And in that image you have to identify your target. And there is nothing more than that. And in the image what you have, number of pixels, for example, it is a 70 square kilometer area, so 70 by 70 pixels. 70 square kilometer means 1 square kilometer has a 1 pixel, so 70 by 70 pixel. And reflectance value of each pixel. And then we have image statistics. So based on this, we have fixed some markers. Next one. We have fixed on the image statistics marker. Median of the image pixel in band 1, median of the image pixel in band 2, standard deviation, all the standard deviation for 4, 5 and NDVI. Next one. So these markers we have fixed, because only these things we have by which we can play and we can say that, or we can identify the target. Then again, in previous slides what you have seen that T2 will be more than 320K, T3 will be more than 8K or something like that. Means what the threshold value? Threshold is a value or any image. We are fixing this value to masking or to enhancement or to get the information, the different information from the image. So what we are doing, what we have done, first we have fixed 5 markers, and then we are not assigning the value, because once we will assigning the value, then again that value will be fixed for that image only, for the next type of image, for next type of thing. So what we have seen that this T4 should be the value of MT4 n minus 1, and then again the challenge is that how we can calculate the value of n or value of n, etc., etc. So this test we had done for the 70 images. For designing an algorithm, we should be the very adaptive for the NOAA MVHR image for detecting the hotspot. Next one. So the again problem is what solution we have, how we can get that. Because we don't have anything, we have only the pixel value, reflectance value, pixel number and reflectance value. So we have solved it mathematically. Next one. So this n is playing a major role, and this is very important, that how we can select the value of n so it can give the highest hotspot detection accuracy and our desired goal can be achieved. Next one. So how we can decide the value of n for the developing the algorithm? What we have done, we have defined the 2 parameters, hotspot detection accuracy and false alarm rate. Means how many pixels directly are it is coming as a hotspot with our algorithm, or what the pixels we are detecting, in that how many pixels they are giving the false alarm. Actually they are not a hotspot, but we are reading the hotspot. That is the false alarm. So next one. So this is the formula we have defined: correctly detected hotspot in total hotspot that exists, incorrectly detected hotspot total number of pixels minus total hotspot that exists. So we have defined the 2 parameters, how we can say that our algorithm or based algorithm. Why I am talking all these things here? Because once we are talking about the images, so a lot of quantitative approach is required. How you can particularly pinpoint, by pinpoint how you can analyze or how you can confidently say that this is your target or it is your not target. So by visual interpretation, as you have seen that it is not possible to see anything. So once you are going in a development of product and all other things, so a lot of things are required to satisfy the end user. Next one. So what we have seen that we have developed some empirical relation, because till now we have decided the markers by these markers. That is, the markers are simply the image statistics, median, deviation, and etc. of the image with some mathematical expression. And because we are very much interested to get this n value with the image only. We don't want to fix. Generally, what the people are doing, thresholding they are fixing. They will start to play with that. For example, if it is a 300, they will start to play with the 200. 200, 201, 204, 206, and they will calculate. They will see that whether your target is becomes highlighting or not highlighting. So our aim is, once we have emails, just to process the things, automatically you can get the result. You don't have to play anywhere. So this is the end value for finding the end value. Why I am showing it? Because the approach is very important. How you are approaching the thing. So this is a different type of approach. So we have seen that this is the data for the result in the M for different values of M. That what we are seeing that this is the HDA, hotspot detection accuracy, and false alarm rate. What we are seeing that as we are increasing the value of M, after the 14 or something like that, the HDA becomes constant, but in the same way, false alarm rate is also increasing. So once we are taking, for example, if we are taking the value of 18 or 20 or 22, here also again means 50% of probability to get the clear-cut target or the false. Next one. So we have developed a relationship. HDA or the hotspot, that is the based on the because it is a function of M. But we have seen that HDA and R is both are very much dependent on the M. So we have developed a function. So this is the function. Next one. So we got the different values for the A1, B1, C1, D1, and these are the some empirical relation. There are three. हम लोग बात करते हैं mathematical models. There are three types of relationship. First is physical, second one is the statistical, third one is the empirical. So what is the difference? Physical based model means what the concept behind that. जैसे आप कहें philosophy behind that. For example, न्यूटन ने दिया. न्यूटन ने क्या दिया? Force, laws of motion. So Newton, there was no computer that time. Only the philosophy was there. So on the basis of the physics or on the basis of the philosophy, so that is known as the mathematical or physical relation. Second, statistical relation. Statistical relation is very much based on the data statistics. What the data statistics are. And third one is the empirical relation, which is a very important. A lot of place you will be reading that empirical relation. Empirical relation means the relation which we are developing on the basis of our experiment. So therefore everywhere I have written the empirical relation. We have chosen 70 images for 10 years, and in that 70 images, because if you are playing with one or two images, then you cannot make that optimal. Because in a very thumb rule, once you are increasing the number of samples, then your results will become more accurate and accurate. और अगर कंप्यूटर साइंस में कुछ काम करना है, तो स्टैटिस्टिक्स की कोई भी बुक है, हेल्स की बड़ी अच्छी बुक है, उसको जरूर पढ़ लीजिए. एंड उसमें लिखा हुआ इकोनॉमिक्स की थ्योरी लिखी हुई है, इकोनॉमिक्स है, बट यू कैन अप्लाई ऑन योर पिक्सल्स. हाउ द पिक्सल्स आर वैल्यूइंग. इकोनॉमिक वैल्यू जैसे वैल्यू के वैल्यू कर रही है, यहाँ मेरे पिक्सल वैल्यू वैल्यू कर रही है. सो इट इज द ब्यूटी कि हाउ यू आर फ्यूजिंग द थ्योरी फ्रॉम वन प्लेस टू अनदर प्लेस. ये so and another thing, therefore I have mentioned that this N is playing a very important role, because what I want, actually I want that we can give an image to a computer programmer. The product is there, just image pass through that product and give. This is the area of the hotspot, this is the temperature of the hotspot, without playing anything. But till now it was very difficult. And these are some processes which I am discussing. Again, R square is known as, there are three type of basic methods for developing any algorithm. Either it should be the philosophical, physical based, or it should be the statistical based, and third one is the empirical based. A lot of people, they are using the empirical based. Empirical based means what the experiment we are doing, the relation on the basis of that experiment. And once we are saying this is the relation, for example, we are saying y is equal to mx plus c is the relation. Y may be the height, y may be the number of pixels of the image, x may be the reflectance value of the image. Nobody is going to believe you. वो कहेंगे ना नहीं तो y इक्वल टू mx प्लस c नहीं हो सकता, y इक्वल टू m by x by प्लस c होना चाहिए. How you are going to convince this कि y इक्वल टू mx प्लस c है या y इक्वल टू m by x प्लस c है. So for that purpose there are some statistical parameters. That this is known as the, once we are talking a relation means how much y on left hand side is depend on the right hand side. Relation का क्या मतलब है? Relation का क्या मतलब है? Relation means simply relation means how much y dependent on x. So therefore we are writing LHS and RHS. RHS is always independent. LHS is the dependent one. So these are the one parameter that is known as the coefficient of determination, or in layman we are saying the correlation coefficient. Correlation coefficient is R, whereas the R square is the coefficient of determination. So first few slides what I have shown you till now, what we are trying to correlate? We are trying to correlate कि either with this reflectance value is it possible to segregate our hotspot or not. So what we have seen that first few slides we have seen that it is possible. Then we are fixing some n values. N values means we are trying to segregate, we are trying to pad, we are trying to mask. The rest should be masked, only hotspot should be come to the picture. So at n, then we have seen that this R square is the coefficient of determination, and it tells about the percentage of dependency on the independent parameter. So that is very important. So therefore we are saying if R square value is more than 0.9, then it means what the relation we are making and we are designing, it is useful. If its value is less than 0.9, it means we have to think again what the relation we are doing. Next one. So therefore it is written. So therefore it is written that the proposed relationship is quite acceptable. Next one. So what we have developed, we have calculated the, as I have mentioned, again for statistical satisfying the result, we have tested the p-values. P-values again with the level of the confidence, either what the relationship we have developed, how much percentage of confidence in the next one. So this calculated as values again, because we are developing some empirical relation. Results what we have found, we have calculated the output pixels, output hotspots, output image of the proposed contextual algorithm, AVHR data, and this for the different bands. A is the AVHR image shown in band 4, B is the output image for that. Similarly, this is for the year 2003, this is for the year 2004. So what we are seeing that after doing so exhaustive application of so exhaustive algorithms and all other things, we are able to detect some hot spots or some points which we can confidently say that either it is a hot spot or not. Next one. Next one. So we have validated the model again, because for development of model there are three phases: development of model, validation of model, and the second phase is the testing of model and the validation of model. So again we have validated the model for the rest 5-year data. Next one. So what we have found that this HTA and FAR exhibit similar behavior for all AVHR data. So AVHR data used for development of the contextual algorithm. So why we are calling it, there are two: fixed thresholding and contextual. Fixed means only on the basis of that pixel or that value. Contextual means on the basis of the pixel statistics. Pixel means spatial statistics. How does one pixel values are changing with the neighboring pixel? That is on the basis of the contextual. Next one. So we have compared, because again it is a matter, once you are saying, because since last 20 years a lot of people are working, so once you are saying, okay, your model is very good, your model is very adaptive. If you are saying your model is very adaptive, then people will say, okay, no, but you are giving more false alarm, then this model is not good. So you have to check how to compare all the different methods. Next one. So we have these are some very famous. If you want, you can write the name of the algorithm. Otsu thresholding algorithm, Sato contextual algorithm, entropy based algorithm. So any image you can apply. This is a very basic image analysis algorithm, and we have proposed contextual algorithm. So Otsu, they have developed the thresholding algorithm on the 1978. Until now, if you will see the research paper, so people will start to work with the Otsu thresholding algorithm. So what you are seeing that? You are seeing that with Otsu, we have developed this one. With Otsu, with entropy based, a lot of false alarm are there. And in passive Sato method is there, only one hotspot. Means also here also we are not, accuracy is not very less. Here false alarm rate is very less. But what we are proposing, because our aim, as I have mentioned, that it is a thumb rule. Once you are increasing the threshold value, so maybe your accuracy will be increased, but your false alarm will also increase. For example, you are taking 90% of the value for the threshold. So a lot of things will come on the picture. In that picture, your target as well as the false alarm will be there. So this is the drawback or the earlier algorithm. Next one. So what we have proposed algorithm outperforms existing ones. Next one. So again, this is some, as I have mentioned, I am very much interested in any quantitative analysis. Okay, how, with the saying, maybe you can say that, okay, this face is not smiling, but you must have some clues, and you must have some idea that you can convince the person that no, these are some 5 or 6 reasons. By this, we can say that it is smiling, face is smiling. हमें देखने में लग सकता है, आपको नहीं लग सकता. आप कहते रहोगे no. Just for looking, it is very difficult to say. So we have again sensitivity analysis we have done just for showing the false and the false alarm and the true positive is the positive or negative. So again, this is the different methods for getting the false alarm and all other things. So sensitivity is the proportional to the pixel. So these are some mathematical analysis which we have done to represent our algorithm that is the best suited for this type of hotspot detection.